Okay, now it's time for clutch function and proper adjustment. This is a cutaway of a 14-inch cast cover, which they all work on the same principle. And primarily the clutch works on a fulcrum. To start out with, we have our throwout bearing. We have our, what we're going to call our half-inch A dimension, which we're going to be talking about extensively here real shortly. We have our cover shell. This is the adjusting ring right here. This is what you turn to adjust the clutch. Now, the adjusting ring, these are the levers. This is your braking point right in here. The adjusting ring is connected to the lever, and then the lever goes down to the actual pressure plate. A lot of people refer to the whole assembly as a pressure plate when in fact this is a pressure plate. How this clutch works basically is this. When the bearing pulls up, the angle spring pressure alleviates, the whole sleeve comes up, the levers move up, and allows the pressure plate to pull up. Something also that's worth noting is, we talk about this half-inch A dimension, why that is so important. At the half-inch A dimension, that's when the clutch is designed to have its maximum plate load, because that's when your spring angle is just perfect. If you alter your A dimension, you alter your spring angle and your spring compression, which you get a slipping sensation or a poor release. Now, we're going to go next and I'm going to show you how to set a clutch up to achieve your A dimension when it's actually installed in a flywheel. We've developed a tool called a Cat 1, and it's very similar to what you guys seen in the introduction when Dwayne was actually setting the clutches up in the Smedberg device. Except this is something that you can do yourself in the shop, and it's very easy. Alright, this is what we call a Cat 1. How it works is, it simply sets on the cover, and this acts as a puller which is going to pull the throwout bearing back away to simulate the travel. Now, this Cat 1, currently we have this thing, the clutch actually mounted on a flywheel. Let's talk about mounting on a flywheel for a little bit. A lot of times people don't really know the torque, the proper torque specs for this is on a 14-inch is 32 foot-pounds of pressure, and on the 15.5 it's 50 pounds of pressure. Now, be sure and put at least Loctite blue. I know some guys will put Loctite red even on. You do not want the cover bolts backing out of the cover. So, also, the Cat 1 again will fit on a 14-inch cast style cover and also on a stamped steel. Now, if you don't happen to have a flywheel sitting around, we actually got what we call a Cat 2. This is basically a flywheel simulator. It's a flat plate. It's dual drilled for the 15.5s and the 14s. Works on the cast or the stamp. Now on the stamp, since that's a recessed flywheel, it comes with adapters to simulate the 2.937 height. So let's show you how this works. We talked before about the A dimension. Now, along with this tool, this is a half-inch thick. This is 1 inch thick. Let's check it. Right now, the cover is set. We've got our half-inch here. And actually, on some of these covers on the later style, you might even have a 9/16 because there's not as much metal on top of the cover as there is in some of the older ones. So anywhere between a loose half, see as this one is not quite going to go 9/16 is all right. Now, this clutch right now is in a full engaged position. Now how the Cat 1 works is, pull the bearing back, just like the guys up in the cab pushing down on the pedal. We're going to pull the bearing back until we have exactly 1 inch underneath the bearing. This simulates the half-inch of travel that it must go through to put it in a release position. Alright, now we've simulated our half-inch of travel. What I've done here is taken one of the plastic alignment tools and cut about 3 inches off of it. Now my tool basically is riding on the rear disc. if you try to do this, do not push it all the way through because there's no pilot bearing in this flywheel, so it's going to cock. At this point, I drilled a hole in it. I'm going to put my screwdriver in here. Right now, that disc is in a full release position. It's sliding back and forth. You can also check it by taking and moving the center plate. We're ready to go. Now, at this point, if I needed to change the adjustment on this cover, I've got all the pressure off of it, and now I can easily turn my adjusting ring. Remove this. How the cover works, if we turn the ring clockwise, the bearing will rise back toward the transmission. If I turn the ring counterclockwise, the bearing will drop down toward the cover. So simply right now, the clutch is in a release position, turning on the ring. Now currently, I'm turning it clockwise. Now I want to note something here. I've adjusted it quite a bit, to be honest with you. Now let's see how our A dimension has changed. I'm going to release the pressure off of it. That's quite a bit. See how much slop my 9/16 has got in there? Now watch something very important. I've drastically changed the adjustment. Now, at this point, the clutch is still in a full engaged position, even though I've radically changed the A dimension. Now, I'm going to pull the bearing up to simulate my travel. I'm going to drop this thing down just like it was before. I've got exactly a ½ inch, but you see the bearing didn't move but maybe a ¼ inch. The thing is in a full release position. A lot of you guys will call in and complain that, hey, this clutch comes in right off the floor. In other words, it goes from engaged to disengaged rapidly. That's because the stroke of the cover has changed. If you have this situation, you must back it off and bring it back down to your ½ inch A dimension. That will get your stroke back on your pedal. So, now, the next thing I want to talk a little bit about is this sleeve. This is called a second generation sleeve. I don't know if you can see it right here, but it's got a big spring on it. This is actually what the sleeve looks like. It's 3 parts: spring, retainer, throw bearing sleeve itself with a centering bushing. This is a self-centering sleeve, but it's very easy to get this sleeve off-center. Watch on the bottom. See how much slop there is in there? This is supposed to be centered. Now, usually when you take the blocks out of a clutch and you don't put them back in, the sleeve is going to cock to one side. If you've set the clutch up just as I have and you want to make sure the sleeve is going to be centered, there's an easy way of correcting this. Relieve all the pressure off of it. Actually, I'm going to take the Cat 1 all the way off. Push down on the bearing all the way down a couple of times and the sleeve will self-center itself. If you've got the cover off, you've got to reinstall the blocks underneath of it, which we're going to do in a little bit here. And you can actually take an alignment, an input shaft, and stick it in the back side of the cover, and you can actually force the sleeve back into center position. If this sleeve is out of line, one thing you're going to notice is you won't be able to get your alignment tool out. Don't get a hammer out, don't start beating on everything. The sleeve itself is out of line and you can correct it. Just take the cover back off, or if you can, push down on the pedal even though you got the alignment tool in there. And you should be able then to just pull the sleeve right back out again. Okay, I've readjusted the clutch down where I got my 1/2 inch A dimension back again. Now it's time to set the blocks. Normally, at this point, the blocks should just fall out. If you reset blocks, watch the bottom of the bearing cage. Don't set the blocks here or here. And also, some of these bearing cages have like a button sticking out down here. Do not set it on the rivet head or the button head. You have to offset it, because otherwise it's going to hold the bearing up too high, and when you go to pull your alignment tool out, your discs are going to fall down. So just kind of a caution when setting blocks. Now, we've talked about the A dimension. This should always stay constant for the life of the clutch. You should always maintain your 1/2 to 9/16. But the other dimension, which most of you guys are concerned with, is the distance between the throwout bearing and the clutch brake. Okay, yeah, you want 1/2 inch to 9/16 here, but sometimes you may have more than that. And what this is due to is something that we would call flywheel wear. Flywheel wear is not, hey, this flywheel needs to be turned. Flywheel wear is how many thousands have you taken out of that flywheel in its entire lifetime. And when we get to the next section, we're going to go into this in depth. We'll show you how to measure a flywheel to actually see what's been taken out of it. Now, keep in mind, every time you turn a flywheel, you're moving the whole clutch assembly closer to the engine, farther away from the transmission or from the clutch brake. Do not, on the initial installation, when you're setting up that new clutch to get your 1/2 to 9/16, do not bring the clutch to the stop brake. You bring the stop brake to the clutch. Now, there are several ways of achieving this. Number one is you put a new flywheel in. That'll solve the problem. Most guys don't want to spend the money for a new flywheel. Number two is you put a shim or spacer in. Now, when I first started in the clutch business, every clutch had a 3-piece clutch brake, 2 fibers and a metal. Well, a lot of the old guys would keep the fibers, and that's what they would use for their spacers. They'd put 1 or 2 of these in every time they put a clutch in, and that's how they took up and got their 1/2 inch right here. Well, we've gotten a little bit more sophisticated these days. We've got the hinge style brakes now, but we also have oversized clutch brakes. A standard clutch brake is 375 thousandths thick, 3/8 of an inch. They actually make a standard. They make a 440 thickness, which is actually 65 thousandths thicker than normal, which is basically 1 flywheel turn. And they have a 500, which is a 1/2 inch thick, which is 125 thousandths over, which, by the way, is what the fiber washer is. It's 125. Now, if you got a 1-piece clutch brake in there, you don't want to be taking the brake out. You can take these fiber spacers, and if you measure properly, you measure 1 inch. First of all, draw you a center line, measure 1 inch on the inside, 1 3/4 inches, and take a tin snip and cut a pie wedge out of it. Now, a lot of guys say don't do this. I say do it. Soak them in hot water for a little while. That way, when you're trying to install them, they won't crack or break. I've done a lot of these where I've just taken a big pair of vice grips, clipped my vice grip on, had a ball peen hammer, put it up on the shaft, and just pop it on the shaft. I was in a shop one time in Nebraska, and the guy had the perfect answer. He actually took a hammer handle about that long, with the head off of it, of course, and he stuck this right down in that top of the slot of that head. That way it was outside the bell housing, took it, popped it right on the shaft. Keep in mind, all this is going to do is when the clutch moves back a 1/2 inch, the clutch brake stops the input shaft from turning so you can go into first or reverse. Otherwise, the clutch brake is not even relevant. So that is all it's supposed to do. So always remember to get your ½ inch, you get your ½ inch here by bringing the stop brake to the clutch. Your A dimension right here is preset at a ½ inch. The next thing you want to do is you want the distance between your fork and your throw-up bearing pad. This should be 1/8 of an inch. This is what actually gives you your free pedal up in the cab. 1/8 of an inch down here between the bearing pad and the fork will give you 1.5 inches, virtually to 3 inches, depending on your linkage wear. That's what you want to do. Now, you set the linkage to get your 1/8 inch right here, and you never touch the linkage again in the life of the clutch. Because the linkage is going to be your gauge or your standard telling you when to adjust the clutch and how much to adjust the clutch. Because what's going to happen is, as this all wears, naturally from the component wear in here, the bearing will come down, will make contact with your fork and your bearing pad. You have no free pedal. That tells you right there it's time to adjust the clutch. By turning this ring clockwise, two things happen. You turn the ring clockwise, not only will the bearing come up to give you your 1/8 inch clearance back here, but the pressure plate is driven deeper into the flywheel to compensate for your component wear. The linkage adjustment is done on the initial installation. No more linkage after that. Always do the internal adjustment after that to get your proper free pedal and your proper adjustment.